Okay, so we are looking at the chi-square test. We're just trying to find out if two things are dependent on each other, meaning there's a relationship between the two things, or if they're independent of each other, meaning there is no relationship between the two things. Okay, so we have a question here. It says a teacher wants to find out whether students' preferred learning style, visual or auditory, is related to their test performance, pass or fail. Data from the 40 students are summarized below. Okay, so here we got pass or fail. This is the test performance here, and then the learning style, visual, auditory. Okay, so 12 people who chose the visual learning passed and 8 of them failed. 10 people who underwent auditory learning passed and 10 people who underwent the same auditory learning, they failed. So we want to find out if the learning style and the test performance are related. Okay, so step 1, form the null and alternative hypothesis. Okay, the null hypothesis is always saying there is no relationship. Okay, so in this case, learning style and test performance are independent. There is no relationship. The alternative hypothesis, H1 or HA, is saying the learning style and the test performance are dependent. There is a relationship between the two. Okay, so that's the first step. You form the hypothesis. Okay, step 2, let's get the totals, get column totals and grand total. Column, row and grand totals. Okay, and we move step 3 will be the expected frequencies. Yeah, so basically just add 12 plus 8, 20, 10 plus 10, 20, 12 plus 10, 22, 8 plus 10, 18. Okay, so these are the column totals, these are the row totals. Then the grand total, you can either say 22 plus 18, that is 40, or you can say 20 plus 20, that is 40. Any questions before we now calculate the expected frequencies? Okay, so to get the expected frequencies, all right, this is the formula: row total multiplied by column total divided by grand total. Okay, let me just also bring the table for the expected frequencies so that we see this. Row total multiplied by grand total or row total multiplied by column total divided by the grand total. Put this side by side because this is where the part where it gets confusing for a lot of students. So let me put this side by side. So for visual and pass, okay, we're looking first at visual and pass. We're going to say the row total is 20. Column total is 22. And the grand total is 40. Okay, so we are going to say for visual and pass, we're going to say 22 multiplied by 20 divided by 40. Okay, 22 multiplied by 20 divided by 40, and we got that answer here. We get 11. Okay, just do row total multiplied by grand total. Row total multiplied by column total by grand total. So 22 times 20 divided by 40, you get 11. This is for this one here. Any questions before I go to the next one? Okay, we come to this one here for fail and visual. Okay, so we're going to say row total 20 multiplied by column total 18 divided by 40. Okay, row total, column total divided by 40. Okay, so let me get the tabulation there, down here. Hmm. 20 times 18 divided by 40, you get 9. Okay, that's for visual and fail. Okay, then we come to auditory and pass. Okay, row total 20, column total 22, grand total 40. When you do our tabulations, you get 11. Okay, that was for auditory and pass. Okay, column total, and then this row total divided by the grand total. Then finally we go to auditory and fail, this one here. Column total 18, row total 20 divided by the grand total, which is 40. 20 times 18 divided by 40, we get 9. So these are our expected frequencies. Basically, these are just telling us if our null hypothesis was true, this is what we expect to get. Okay. Any questions? Okay, so this is how our new table will look with our expected frequencies. Okay, you've got the observed frequency and expected frequency. Okay, after that, now we need to calculate our chi-square statistic. Okay, our chi-square statistic. So this is the formula for the chi-square statistic. Okay. The summation of the observed value minus the expected value squared divided by the expected value. Okay. So we start here. 12 minus 11 . You square that and you divide it by 11 because the expected value is at the denominator. So set 12 minus 11 squared divided by 11. The next one, 8 minus 9 squared, observed value 8 minus expected value 9 when you square it, divided by the expected value which is 9, so you put there. The next one for auditory here, observed value 10 minus expected value 11. 10 minus 11 squared divided by 11. And then finally here, 10 minus 9 squared divided by 9. Okay. So once you do our tabulations, we eventually end up with 0.404, which is our test statistic. 0.404. This test statistic is going to be compared with the critical value from the table to see whether we can reject or fail to reject our null hypothesis. Okay. So once you've got your test statistic, so don't let me connect something for the battery dies down. Yes. So step 5, we need to get our degrees of freedom and the critical value, which will compare with this test statistic. Okay. So just remember, with all hypothesis tests, you're comparing a test statistic with the critical value. So we get our degrees of freedom. Okay, degree of freedom, it's the number of rows minus 1 multiplied by the number of columns minus 1. Okay, number of rows, here we have visual and auditory, so we have 2 rows. Number of columns, pass and fail, so we have 2 columns. Okay, this here, which is row total, let me remove it here. Not even be there. Don't count this row total. Okay. Yes, and also this column here. Don't count it. Okay. Just see what you're testing. Okay. So here 2 rows, visual and auditory, 2 columns, pass and fail. So 2 minus 1 multiplied by 2 minus 1. 2 minus 1 is 1 times 1. We get a degree of freedom of 1. Once we get our degree of freedom, and in the question I think they gave us our significance level. Forgot to put that. They will give you a significance level in your question. In this question, we are using a significance level of 5%. Okay, they will usually tell you. Just forgot to put that when I was making this question. So we are using a significance level of 5%. What the significance level is, colleagues, is just saying we are not 100% certain what our in life you're not never 100% certain of anything, so you leave room for errors. Okay, leave room for errors or chance. Okay, because you're not 100% certain of anything. That's what our significance level is saying. So when you go to your chi-square table, okay, you have your degrees of freedom here, this main column here, degree of freedom here, and then you have this main row for your significance level. Okay, so a 5% significance level is this one, 0.05. Okay, 0.05, this is a 5% significance level. A degree of freedom, 1. So where these two intersect, that's your critical value, which is 3.841. Okay, so in this graph for the chi-square here, it's like the 3.841 is here, this critical value is just separating these regions. They fail to reject region and they reject region. Okay, so once you've got your critical value, you compare it with your test statistic. Okay, remember we got 0.04. okay, this is what we calculated, 0.04. Now since our test statistic is less than the critical value, we fail to reject the null hypothesis. Okay, when your test statistic is less than your critical value, when your test statistic is less than your critical value, fail to reject HO, the null hypothesis. Meaning the null hypothesis is true. There is no relationship. Okay, there is no relationship between the test performance and the learning style. Okay, so that is the conclusion of our test. Since our calculated chi-square statistic, which is our test statistic, was less than our critical value, so we failed to reject the null hypothesis, which is basically telling us that there is no relationship between the learning style and the test performance.